a new episode of Passion for Technology, the podcast from EPD Electronic. Great to have you with us.
Welcome to the Passion for Technology podcast. Today, we're diving into a revolution that's reshaping our digital world. Picture this. By 2028, our connected devices will generate an astounding 400 zettabytes of data globally. To put that in perspective, 1 zettabyte equals roughly 12 billion 4K videos. This massive surge, growing 24% annually according to IDC, presents both challenges and opportunities. While we often hear about processing power and CPUs enabling AI at the edge, there's another crucial piece of the puzzle that deserves our attention: memory technology. After all, even the most powerful processor needs somewhere to store and access data. Joining us today is David Henderson, Senior Director of the Industrial Segment at Micron Technology, to help us understand the critical role of memory in edge computing. Hi, David.
Hello, Mustafa. Nice to meet you.
Good to meet you too. David, let's start with the basics. Where does edge computing shine in today's digital landscape?
Yeah, edge computing is very important inside of the landscape today. It sits in the middle of the endpoint devices and the data center. And it's really something that's evolved as technology has evolved in driving the speed of decision making. So capturing and managing data at the edge allows for lower latency of processing data, lowers the cost of having to send data to the cloud. And it really is ideal as we see the number of sensors, endpoints, business models that are being generated around this, not just ingesting more data, but driving higher fidelity, higher quality actions and activities such as the videos and the inference that comes all closer to the data. So this equates to a need for more memory and more storage to support these models. And that's why Micron is involved and very interested in what's happening at the edge.
Could you share some examples of how organizations or applications are leveraging edge and cloud computing to create optimal solutions?
Yeah, absolutely, Mustafa. Edge computing is really being leveraged in all industries. As an example, we see advantages in a typical factory floor. So edge computing allows the monitoring of a machine's operation, can offer predictive maintenance to be implemented as a way to reduce downtime and keep the machine up in optimal performance range. The machine's motor vibration, gear friction, back wear can all be managed in real time. Instead of sending those time series data up into the cloud, which can become expensive and slow, edge computing allows for on-premise analysis of optimal machine adjustments. So while sending only general condition tags up to the cloud for more broad factory-wide analysis. So that's an example of what happens in factory automation. But we really see the edge being leveraged and used across multiple different applications, including video security, including machine-to-machine and cellular IoT, including medical. So it really is the broad range that are driving towards an edge type of solution that fit into the overall ecosystems of how our customers are delivering value and solving problems.
So beyond processors, memory plays a crucial role in computing. How does storage technology specifically enable modern applications?
Right. So edge applications leverage AI that's designed for local inference. These AI models are data hungry, and it allows them to increase and improve the best predictability in their decisions. So high-speed DRAM density and bandwidth are key for processing the data, but storage from devices such as eMMCs or even NVMe SSDs are critical as both for the business model data as well as activation data for the neural network.
As processors become more powerful, networks faster, and bandwidths increase, how have storage requirements evolved?
Yeah, memory and storage requirements have had to keep pace with the latest CPUs, FPGAs, and even ASICs that are being used at the edge. For one, these CPUs have increased the number of processing cores, so it's not unheard of to see octal cores for small devices or up to 64 cores or even more in edge server-like devices. These all require a whole lot more bandwidth and memory density to operate efficiently based on their use cases. So with the advent of AI technologies such as GPUs, these requirements have increased even more. So regarding storage, typical industry use cases in the past have leveraged lower density solutions like 8 gigabyte eMMC as an example. But with edge computing, these storage densities that offer both code and cloud agent software, we see these growing 64 to 256 gigabytes. So storage drives have moved from standard SATA to NVMe SSDs, and that offer the PCIe interface as well as some of the new features to help manage data such as SRIOV.
So you've mentioned efficiency, and you've also mentioned interface technologies and protocols. What role, let's dive a little deeper into those aspects. What role do power efficiency and form factors play in memory modules for edge applications?
Yeah, good. So similar to endpoint solutions that leverage them, as well as data center solutions, edge applications require a range of optimization around both power and form factor. So power on the edge is extremely important for designers. Memory and storage is a part of that overall subsystem. And so power is an important consideration as a part of that overall system. In memory and storage terms, power efficiency measures the amount of data that gets processed or stored per unit of energy consumed. So as an example, a solid state drive are generally more power efficient than a traditional hard disk drive because they lack the moving parts that are required for a hard disk drive. So this results in lower power consumption, driving both the active and idle states, making SSDs particularly beneficial for involving something that frequently moves data across the system. Form factor is also crucial, not only from a size standpoint, so there's a physical dimensionality that shows up in our customers' architects and designs, but there's also the alignment and compatibility with the motherboard and the processing pieces that are involved in the design. So you can only install memory or storage devices that fit a designated slot. And so form factor is very important as well in edge devices.
David, what's your advice for engineers designing edge devices? What are the key considerations when selecting memory solutions?
Definitely, you have to start with the use case. All of the folks that are listening to this podcast know that, starting with the use case. And edge system use cases continue to get more complex, getting more complicated, adding AI into hardware, adding multi-port gigabit Ethernet, multi-stream video, machine vision interfaces, et cetera. So these systems are becoming more and more complex. And depending on the application, the demand for memory and storage can vary significantly, all the way from a very low density solution all the way to a very high density solution. And so it's really start with the processor architecture, understand the data workload, both in compute and storage, and then tune in on the memory that fits that. But the one thing I would say here is the speed with which our industry is evolving. It's definitely to our designers' advantage to think about future-proofing their designs now. And so within the operational flow, redesign or requalification is not a popular activity, right? And so as designers can consider the possibility for future growth in the software, in the application requirement, it's a great idea to think about future proofing, both in terms of the size of the density, the amount of bandwidth that we're planning for, and even up into some of the ruggedization of products that, we can start with a core design and move it to different markets. I know a lot of our customers are big on having a core fundamental design that then gets leveraged to sister designs over time.
Now that you've mentioned ruggedization, edge devices often operate in harsh environments, unlike data centers or with home PCs. How does this affect storage requirements? What should a developer of edge devices be aware of with respect to, let's say, environmental parameters?
Yeah, for sure. A strong concern in the industrial segment. So not concern, it's a consideration and really a use case environment that has to be planned for and designed for. So many of the edge devices, as you mentioned, are on premise where the data is being gathered. And this can be in multiple locations in the industrial segment. So it can be on a factory floor, it can be in a steel mill, it could be on a construction site, or even in the middle of a cornfield and while it's snowing, right? And so having rugged solutions that can operate in harsh conditions are key. You might not have the option of air controlled environment as you get out into these environments. And so having IT grade components available to accommodate fanless operations will be important, as well as ensuring that the quality of product that is being purchased has been tuned for ruggedization and shock and vibe, as well as has an overall higher level of quality than maybe something that would show up in a consumer device or something that's in a controlled environment.
Shifting over to, let's say, AI applications or capabilities, as those expand across computing environments, what implications do you see for memory technology? Dedicated AI chips are already enabling AI applications on edge devices. What does that mean for memory solutions?
Yeah, AI inference enablement can come in many forms. And so it can be in NPUs with an SoC, it can be in a dedicated AI chipset, or it can even be a part of a subsystem in an FPGA. So whichever way the AI shows up, chipsets require I/O width, speed, and memory densities that are higher and growing to support them. So these chipsets typically use a wider I/O, so a by 32, by 64, or even by 128, and speeds that are pretty high. 8.5 gigabits per second per pin is common, but even up to 9.6, which is found in some of our LP5X technologies. And so in addition, the density needs are growing as well. So we see 32, 64, and 128 gigabit density requirements as baselines for the operations inside AI models for these chipsets.
David, could you give us a glimpse into Micron's R&D? What innovations in memory technology are on the horizon?
Yeah, memory is an exciting technology, and it is becoming more and more important in the system design. The complexity of storing, reading, writing, and managing every digital bit of data, but also the technology needed to produce a single chip. We are very proud at Micron at the level of importance that memory has inside of the subsystems that are being developed across all industries, including edge compute. Micron brings value to our customers by offering leading edge technology nodes. We're best in class in the industry in DRAM and in NAND storage in both performance, power, efficiency of operations, densities, while innovating with our customers on how to make sure that memory can be used in the most strategic way inside of our systems. So there are innovations around HBM, around CXL. We're first to market with DDR5 or LP5X. These are all examples of R&D that we pride ourselves in, and Micron will continue to be out in front in developing the latest and greatest technology and increasing the envelope for performance and density that's needed in this very hungry and growing market that AI is driving. We're very excited about this space. We expect that as AI gets closer to the edge, the importance of memory and storage for these applications will continue to grow, and we will continue to explore, study, and produce new products that fit the market.
How do you envision the future of distributed computing where both, edge and cloud play to their unique strengths?
Yeah, we know that accelerated compute in data centers are transforming the industry and shifting from virtualized functions in CPUs to much higher performance in GPUs and accelerators. But the growth is a foundation to implement the explosion of end devices, AI-enabled application systems. So we see edge compute will be critical. We see this is really the land where new business models will arise, new hardware and software systems and combinations get enabled, and new compute architectures get realized. Really, we believe that the edge is where a lot of the innovation will be happening that'll be generating new business models and new value propositions from our customers as they move forward and offer new offerings that make life better for their end customers. So I expect then a more distributed network where, the edge becomes the bridge of compute and decision making.
Which is also something that I'd like to, have you elaborate a little more on. I mean, David, how critical is edge computing in driving digital transformation? What's your take?
As we see machines and even whole factories have digital twins, we can only imagine the use of both the real data as well as synthetic data to add to the level of digitization of all elements in our physical world. Just like people occupy the physical footprint in which we stand, data and information will occupy the digital space in the form of memory and storage. So key to advancing digitalization is the ability to support the zettabytes of data that it will generate, and memory and storage are just a critical piece of how that will happen at the edge and how it will get implemented.
David, before we wrap up, I'm curious, what sparked your passion for technology? What's your origin story as a technologist?
That's a great question, Mustafa. Give me just a sec to kind of generate that. Because
anytime, I'll tell you mine real quick.
Yeah, thank you.
As a kid, I had a cousin of my dad's who was the first computer scientist in the family, and he had an Apple II. And on his Apple II, I played Choplifter for the first time. And then they got me a Atari VCS with Space Invaders. And then, this is the time when Tron and War Games made it into the movies. And that, holy trifecta plus one, that completely got me hooked.
Got it. Okay, great. I have a very similar experience. If I go way back, I was using DOS, the first laptop when I was 10 years old or so, and trying to code in DOS to communicate with it. But then the evolution, I think I caught up to Pac-Man. I got an Atari ColecoVision, for those of you that would remember that. So being connected to some of the video technology early was really kind of sparked me up. But I have to tell you, it continues to grow, and it continues to grow in really just neat and exciting ways. If you look at some of the advancements that are happening on planet Earth that are really making life for humans better, a lot of it is around the development of technology. And so you can see it in the medical field and industrial, in kind of some of the care for our elders, some of the way that people are more healthy. That trend on what we're applying technology for is just a really exciting one that is pointed at making life better for humans. And, that continues to spark my excitement, my passion for memory and doing our part in the overall technology story that helps to make the world a better place.
That's awesome. That sounds awesome. And with your outlook and with your continued motivation for your continued passion, I couldn't agree more. Thank you, David, for the insights that you've shared with us today. And to our listeners, you'll find additional resources in our show notes. Don't forget to subscribe to Passion for Technology on Spotify, Apple Podcasts, or your favorite podcasting platform. David, thank you for joining us today.
Thank you, Mustafa. I really enjoyed it.